When we look around us, what do we see? We see all the objects of the natural world, trees, people, buildings. As we look out into space, we see stars, galaxies, we can see black holes. All of this ordinary matter, it may surprise you to hear, is only 5% of the universe. 95% is in the form of dark matter and dark energy, two mysterious objects whose properties we kind of understand, but whose identity we completely do not know. So I guess the question is, how do we know that something like dark matter exists? Well, very straightforwardly, when we look out into space, we can see other galaxies, and we can measure how fast the stars and the galaxies are rotating. Well, it turns out they're rotating far too fast. If we added up all the visible matter and all those stars and dust and gas that we can see, we added all that together, it's far, far, far too low. If the galaxies were rotating as fast as they were, the stars were spinning around the center as fast as they were, on this amount of gravity, the galaxies would be torn apart under its own force. And therefore there is missing gravity, there's missing mass that's required to be in these galaxies and clusters of galaxies in order to hold them together. This is what is known as dark matter, and it's called dark matter because we can't see it, but we know it must be there because we know we are missing a huge slab of gravity. Exactly how much? Well, it turns out that we need 4 to 5 times as much dark matter as there is ordinary visible matter. Think about that for a second. There is 5 times the mass of stuff. We completely don't know what it is. We can't see it, it doesn't interact with us. So although we can't see it, we see its effects through gravity. One of the experiments is, of course, the one I just described, when you look at the rotation of galaxies. But the last video I described, gravitational lensing, you can also see their effect because you see the distortion of light from galaxies by intervening dark matter. So again, dark matter is something that it doesn't interact with us. It doesn't have any electromagnetic properties, it doesn't emit light, it doesn't react with light, it doesn't reflect light, it doesn't diffract light, but we can see its gravity, we can experience its gravity, so we know that something is there. Now what could it be? Well, there are lots and lots of different theories. Particle physicists, they like to say that something called a weakly interactive massive particle, or a WIMP. In other words, an exotic species of particle that we haven't discovered yet, but has very low interaction properties. There are other theories that suggest that actually, maybe dark matter is nothing more than the effect of gravity from ordinary matter in parallel or multiple universes. In other words, in a multiverse scenario, you have a parallel universe whose gravity kind of seeps over into our dimension, into our universe, and creates this gravitational effect. But whatever it is, it's hugely important, and it's one of the key prizes for scientists and astrophysicists right now, is understanding and identifying exactly what this mysterious matter actually is.